All right, guys, here we are with lesson 1-3, part 1, absolute value equations. So 1-3, we're breaking into two parts because it deals with absolute value equations. And then later in the chapter or in the section, it has absolute value inequalities. So we're breaking it up into the two types of problems to make it a little easier for us. So our targets today, we're going to write, solve, and graph absolute value equations. So what you're going to need today is your Springboard book, pen or pencil, and if you need a calculator nearby, make sure you have one because we are doing a little bit of solving today, so it could be useful for you. Okay, so absolute value, if you remember, is the symbols that have like the straight bars, so they show it right here. Okay, with the straight bar on both sides. So their definition of an absolute value equation isn't really helpful. So I'm going to just skip to this math tip here because that is a little more easy to work with. So if you recall, the interpretation of the absolute value of x is the distance the number x is to 0 on a number line. So if you remember from a different grade, maybe middle school math or Algebra 1, remember, if you take the absolute value of something, so I'm just going to make up an example here really quick. So remember, if I take the absolute value of, say, -5, the distance between 0 and -5 on a number line is 5 spots. So if you remember, the absolute value of something is always positive. So the absolute value of -5 is equal to 5. If I take the absolute value of, say, a positive number, like 6, well, the distance between 0 and 6 on a number line is 6 spots. So the answer would be 6. So the absolute value of something always turns it positive. So now if we think about it in terms of equations, an absolute value equation just means that the variable is inside the absolute value bars. So if you have the absolute value of x is equal to 5, what that means is that absolute value, when we don't know what number was in there before we took the absolute value of it. So technically, if I take the absolute value of -5, the answer is 5. If I take the absolute value of +5, the answer is also 5. So since both answers work, they're both technically solutions. So here's my little trick for absolute value equations. An absolute value equation has two bars, so you're always going to have two solutions. Okay? So let's go through these steps that your book did for example A really quick. So here is the equation. We have 2 times the absolute value of x minus 1 minus 5 is equal to 1. Now this is kind of the hardest type of problem you would see. There's a lot going on in this problem. But step 1 is to always isolate the absolute value, meaning whatever is in these absolute value bars, we want that by itself first. Probably should have done that in a different color, maybe blue. So if there's anything outside of the absolute value bars, we need to move it over. So as you can see here, they took this -5 and they added it over. That's how they ended up with that 6. Okay. This 2 in front, well, this is 2 times the absolute value. So in order to get rid of multiplication, they divided it out on both sides and got 3. Once your absolute value is isolated, meaning by itself, you're going to split it into two equations. Okay, so this first equation, it basically looks almost the same. They just drop the absolute value bars. The second equation, the only difference is they just change the sign on the right side. So these two equations technically look the same. It's just one's equal to +3, one's equal to -3. So then when I solve for x and add 1 and add 1, we get two answers here, +4, -2. Okay, so again, absolute value has two bars. We're going to make two equations and get two answers. That's kind of our trick here. So before we jump into the equations from the book, I just kind of want to do some basic examples with you first that are a little easier, and then we'll do some on the try these, okay? So let's look at this example for a minute. The absolute value of x minus 1 is equal to 6. So according to those steps on the first page, we have to isolate the absolute value first. So meaning we need to get this thing by itself. Well, right now it's not by itself. It has a -1 with it. So I'm going to add that over to clear that out. So now I have the absolute value of x is equal to 6 plus 1 is 7. Once we have the absolute value isolated, we split it into two equations. Now the first equation looks basically identical to this problem. We just dropped the absolute value bars. The second equation, the left side is going to stay the same. We just flip the sign on the right side. Now we have no more work to do here because x is already by itself. So in this case, we're done. X is 7 and x is -7. Okay, let's just do another one really quick. These ones always kind of get confusing for some students because they see the 2 on the outside and they want to like distribute it. So absolute value bars are not parentheses. Okay, so you can't distribute into them. All you can do is clear out any numbers around it. So since it's 2 times the absolute value of x, I'm going to divide that 2 out on both sides to get rid of it. Clear. So 12 divided by 2 is 6. Now that my absolute value is by itself, we go ahead and split it into two equations. First equation, generally looking the same. Second equation, the left side stays the same. We just flip the sign on the right side. And this one's done. Okay. So now that we kind of got some basic examples done, let's go back to the book problems. We're going to try a couple together. So let's try these, and we're going to do letter A together. So we have the absolute value of x minus 2 is equal to 3. So in this case, my absolute value is already isolated. There's nothing outside the absolute value bars. So I'm good to go ahead and split this into my two equations. So the first equation looks basically identical to the original. I just dropped the absolute value bars. So I have x minus 2 equal to 3. Our second equation, the left side stays the same. So x minus 2 is still there. We just have to flip the sign of the 3. So now we have 1 equal to positive 3, 1 equal to negative 3. And then we just go ahead and solve this like a regular linear equation. So I'm going to add 2 to both sides here and get 5. And add 2 to this side. So if I have negative 3 plus 2, I'm going to get negative 1. So there's my two answers. So 2 equations, 2 solutions. Okay. Let's go through B. So we have to look at, is our absolute value isolated already? Well, I see a minus 4 out there, so no, it is not. I'm going to go ahead and add that 4 over to get it on the other side. That way now my absolute value is all by himself. Negative 2 plus a 4 is going to give me positive 2. And now that we have an absolute value all by itself, I'm going to go ahead and split it into my two equations. So again, no thinking really for the first equation. Just kind of copy it down. Just drop the absolute value bars. The second equation, we keep the left side the same, and we just flip the sign of the right side. So this one will be equal to negative 2. So then if I go ahead and solve these two linear equations, I just have to subtract 1 on both sides. So 2 minus 1 is 1. Negative 2 minus 1 is negative 3. There's my two answers. So again, if you're not getting two solutions for these, you're missing that part where we split the equation. So always make sure you have two answers. Okay. Let's look at C. So we have the absolute value of x minus 3 plus 4 is equal to 4. So what should we do first here in this problem? Well, hopefully you said we want to isolate the absolute value, okay? So I'm going to subtract 4 on both sides. So 4 minus 4 is going to give me a 0. Now, normally for this one, we would split it into the two equations. So I'd have x minus 3 is equal to positive 0. X minus 3 is equal to negative 0. But for 0, that really doesn't make sense, right? We don't actually have something called negative 0. So this is the only time where you're going to get one solution, is if your right side is 0. Because there's no positive and negative 0. 0 is just 0. So in this case, I only get one solution, and that answer is 3. Okay. All right, before we do D, because that one's kind of a trick question, I'm going to have you guys try one on your own. So this is not in your book, so just do it like on the side somewhere. I want you to try this number 3 on your own. So we have the absolute value of A plus 5 plus 3 is equal to 10. So go ahead, we're going to pause the video here, and I want you guys to try this problem. Okay. If you got it correct, you should get these two answers. So you should get that x is 2 and x equals negative 12. Okay, going back, I'm going to go look at D now. So I have the absolute value of x plus 3. Smaller, so it's out of our way a little bit. So the absolute value of x plus 2 plus 3 is equal to 1. So our first step is always isolate the absolute value. So I'm going to subtract the 3 away from the absolute value side. So that way my x plus 2 is all by itself. 1 minus 3, that's negative 2. Okay, so here's why I said this is kind of a trick problem. Is because we're taking the absolute value of something, and let me go back up to here where I explained it. Anytime we took the absolute value of something, the answer always turned out to be positive, right? So if I look at this problem here, I have the absolute value of x plus 2 is equal to negative 2. Well, when I take the absolute value of something, it doesn't really matter what x is. The absolute value will always make it to be positive on the outcome. So in this case, an absolute value can never equal a negative. So let's just make a little note on the side here. So absolute value cannot equal a negative number. So if this ever happens to you, where your absolute value is all by itself, but your right side is a negative value, we have no solution. Okay, now that's different from, say, the example above, where I had the absolute value is equal to positive 2, and then I split it, and then we flip the signs. That's different. I'm talking about if your absolute value set up is equal to a negative value, that cannot happen. Okay, so if that is ever the case for you, you don't have to do any work. Stop the problem. The answer is no solution right away. Okay. All right, I think that is enough for today. So just getting those absolute value equations. So again, if you just remember the steps, make sure you're isolating that absolute value first. As long as the other side's a positive number, you can split it into your two equations. Once it's split, then you can go ahead and solve for your two solutions. So make sure you're getting two answers every time, except for that special case when we have a 0. Okay. Okay, that is part 1. So we are good with that lesson. And we'll see you back for part 2 when we do inequalities.